Hello! Welcome back to ClearML. My name is Victor, and in this video, I'll be going through some CI/CD tips and tricks you can do with ClearML. For this video, I'm going to assume that you already know about ClearML and CI/CD in general. The CI/CD stuff will be relatively easy to understand, but if this is your first time working with ClearML, you better check out our Getting Started series first. Now there's 3 specific CI/CD jobs that I want to talk about in this video that you can accomplish with ClearML. The first job is about visibility. Imagine I have an experiment that I'm tracking in Git somewhere. I open a new PR to add a new feature, and now I want to make sure that ClearML has at least one task in its database that has been successfully run using this PR code. Right? To make this very visible, I want to automatically add the model metrics from that task as a comment on the open PR. The second job is similar to the first, in the sense that I still want to take the task that corresponds to the open PR's code. But in this case, I want to make sure that the model residing in this task is equal or better than the previous best model in ClearML. I can easily keep track of that with tags in the ClearML UI, and in this way, I can always guarantee that my main branch contains the best model. Finally, for the last job. Usually I use my local computer and environment to quickly iterate and develop my code, and then only later I'll send it to a ClearML agent to be executed remotely and properly trained on some GPUs, for example. Now, to make sure that always works, I want to add a check to my PR that basically checks out this PR code, runs it on a ClearML agent, and then listens to it. And the moment that the ClearML agent starts spitting out iterations, it means that the whole setup process was successful. And in this way, I can make sure that every single commit in my main branch is remotely runnable. Right, so those were the 3 jobs that I want to talk about in this video. Let's get started. So as you can see, I have here my example project with me, and there's a few things immediately apparent. So one is we have the .github folder with workflows. We're using GitHub Actions in this specific video. Again, you don't have to use GitHub Actions if you don't want to. It's just as an example for general CI/CD stuff. Then we have a few scripts here, and we have our task as well. Now I'll start with the task because that's the thing we're going to run. That's the experiment you want to keep track of in your Git and in ClearML. And in this case, we'll just take like a dummy task. We'll take a very, very simple example here. So we just do import from ClearML import task. We do the task.initialize. If you're familiar with ClearML, this will be very familiar to you as well. It's just the task.initialize, give it a project, give it a name, and then I basically always set the reuse last task ID to false, which basically means that it will never override the previous task if it didn't complete properly. It's more or less a thing of taste. Then I set the random seed to something completely random. And then 10 times, basically, we're going to be reporting a scalar, which is called performance metric, in series 1, and it will have a random value. So in this case, it's super simple. It's just a dummy task. This, of course, this report scalar should be your metric, your output metric that you're trying to check. Could be F1 score, could be MAP, whatever takes your fancy, right? If I then go to ClearML itself, let me make this a little bigger for you. If I then go to ClearML itself, you'll see the dummy task right here. So we actually take care of the repository here. We also have the commit ID, which will come in handy later. And then we also have the script path and the working directory. As you might know, we also keep track of any uncommitted changes. So if you add anything in the code that isn't already tracked by Git in itself, we also take care of that. But that will come in handy a little bit later as well. We also keep track of install packages and stuff like that. In this case, of course, we don't really keep track of very much. It's only the task.init and then just reporting some scalars. But what we do have is some scalars. So this is what it would look like, and we'll be using this one later down the line. Right, so if I go back here to my code, you can also see we have a .github folder with the workflows subfolder in there. This basically tells GitHub that whatever you do, a push or a commit or whatever, it will check this YAML file to see if it has to do any kind of checks, right? In this case, we'll call it ClearML checks, and we'll set the on to pull requests. Now, most of the time that you're using ClearML, it's going to be interesting to do checks on a pull request because it can take some time. It's machine learning after all, but it highly depends on what you want to do, of course. Now, I'll be setting it to pull requests, specifically to branches main. So if I want to do a pull request to my main branch, I will want those checks being fired. And then I want them to be added to several different actions there. Specifically, the edited and the opened are the ones that I'm interested in. So every time I open a PR, but also every time I update a PR, like send a new commit to it, it will trigger. And then what do we actually want to trigger, right? So this is the meat of the story. This is the jobs. In this video, we're going to run 3 specific jobs. One is task stats to comment, the other one is compare models, and the third one is test remote runnable. Now, the first one, task stats to comment, basically wants to take a task that corresponds to the code you're trying to merge, and then add a comment on the PR with the different performance metrics from ClearML. So that it's like kind of neat, you can easily see what the task is doing, how good it is, stuff like that. So that's what we're going to do first. Now, how this is built up, I'll run down this and then we'll go into the code later in a second. But then to start with, we have the environment variables. Now, to be sure that the GitHub action worker or the GitLab runner or whatever you're going to run these actions on has access to ClearML, you have to give it the ClearML credentials, right? And you can do that with the environment variable ClearML API access key and ClearML API secret key. These are the keys you get when you create new credentials in the main UI, in the web UI. In this case, I'll get them from the secrets. I've added them to GitHub as a secret, and we can gather them from there. Same thing with the ClearML API host. In our case, it will just be app.clear.ml, which is the free tier version of ClearML. You also want a GitHub token because we want to actually add a comment to a PR, right? So we also need the GitHub token, which is very easy to generate. I'll put a link for that down in the description. Then we also have the commit ID. So specifically, we want the pull request head shell, which is the latest commit in the pull request. We're going to do some things with that. We'll run this job basically on Ubuntu, and then we have some steps here. So first, we want to check out our code, which is just a PR. Then we want to set up Python with 3.10, which depends on whatever you might be running with. And then also install ClearML. So we have some packages here that we want to install in order to be able to run our code. Now, most of the time, I like to just have a very simple job like this that just uses a Python script that does the actual logic, because command line logic is not very handy to work with. So it's usually easier to just use a Python file like this. So we'll be doing Python task stats to comment.py, which we'll check out right away. I'll collapse some of these functions for you because they're not actually that interesting. Most of the code here is not related to ClearML specifically. It's mainly related to getting the comment out to the PR. But in this case, we'll just walk through the if name.main and we'll go from there. So first off, this is running on a PR, right? So we want to say we're running on the commit hash with the commit hash just so we know. And then we already have our first interesting function. So the first step that we want to do is to make sure that we already have a task in ClearML, present in ClearML, that basically runs the code that wants to be committed right now. So we have to check that the two are the same, right? We have a PR opened right now, we have a commit hash, we want to check if that commit hash is in any of the tasks in ClearML. So we can say like, this is the code in ClearML that we want to track, right? So we know where to get the statistics, basically. I'll check this open. So this is the first cool thing, is querying. A lot of people don't know that you can actually use the ClearML SDK to just query the database in ClearML. So in this case, I'll want to query all of our tasks with the task filter, basically order it by the latest first, then set the script version number, and the script version number tag, or the key here, actually corresponds here to the commit ID. So we'll basically get this. And I want it to fit the commit ID that we get from the PR, right? So now we've opened the PR, we get the commit ID that is the latest. In this case, you'll see actually here, it's this one. So the commit ID is the one that we set here as the pull request head. We get that from the environment here and pass it to this function. And if we go to this function, this commit ID, we basically want to check if this committed ID is already in a task in ClearML. And I also want the task to be completed. I don't want any failed tasks here. We just want to make sure that the code can run, right? That it all has already run in ClearML. And I also want the script diff, which is the uncommitted changes, as well. We'll check that in just a sec. So basically, this query will just return all the tasks that fit these descriptions. Basically, every single task that was run on this code base, essentially. But we don't just want the commit ID to match, we also want to make sure that there weren't any uncommitted changes. So we make very, very sure that the task in ClearML has the exact same code as the PR we're looking at right now. So we basically check if tasks, so if any tasks were returned, then we can go through them. If none of these tasks, if no task was found, so if no task was found, we basically want to raise a value error saying you at least have to run it once in ClearML with this code base before you can actually merge it into main. Seems like a reasonable request. If we actually do find a task, we go for each task in the task. There could be multiple, but again, they're sorted on last update, remember? So we just can take the first one. And then if not task script.diff, basically if there's not any uncommitted changes, we know the exact code that was used there, then we can just return the task. And that's it. So now we have our task object. We know for sure that it was run with the same code as was done in the PR, and we also know that it was completed successfully. So we want to add a tag, for example, main branch. Just in your ClearML, you will be able to see a tag there, main branch. Then we also want to get the statistics, right? Because we still want to log it to the PR as part of a comment. So if I go there and open it up, we first get the status of the task, just to be sure. Remember, we queried on completed, but something else might have happened in the meantime. If the status is not completed, we want to say, this is the status, it isn't completed, this should not happen. But if it is completed, we are going to create a table with these functions that I won't go deeper into. Basically, they format the dictionary of the task scalars into Markdown that we can actually use. Let me just go into this though one quick time. So we can basically do task.getLast scalar metrics. And this function is built into ClearML, which basically gives you a dictionary with all the metrics on your task, right? We'll just get that, format it into a table, make it into a pandas data frame, and then tabulate it with this cool package that basically turns it into Markdown. Right, so now that we have Markdown in the table, we then want to return results table. You can view the full task. This is basically the comment content, right? This is what we want to be in the comment that will later end up in the PR. If something else went wrong, we want to log it here. It will also end up in the comment, by the way, so then we know that something went wrong from the PR itself. Right, so this is what get task stats returns. So basically in stats now we have our Markdown that can be used to create a GitHub comment, and then we have create stats comment, which just uses the GitHub API to essentially get the repository, get the full name, take your token, and then get the pull request and create the comment using the project stats that we give here. Now to check if everything is working, we can open a new PR. For example, I'm here on the branch video example. I'll just add a small change here, just so we know that everything, that there is a change, and then we'll add a PR. So add PR for video example. There we go. Let's do that. Publish the branch, and then I can create a pull request straight from VS Code because it's an awesome tool. Created, and now if I go to our PR here, which we can go into in GitHub here, you can actually see that there is a little bubble here. It's already checking everything that it should. So you can see here, we have the add PR for video example. We changed our tests here, or test 5 here, and you can see all the checks here. So task stats to comment is the one that we're interested in right now. It will basically set up everything, install ClearML, and then run the task. Now, no task based on this code was found in ClearML, right? Because we just changed the code, it has an uncommitted change, remember? So there is no task in ClearML yet with the change that we just made. So in order to get that running, we have to go into task, run this first with this new PR. And now we actually get a new task right here with the exact commit in branch video example without any uncommitted changes. And if we now rerun our pipeline, we should be good to go. So let me just go there. It is almost done here. Yep, it's done. So this should now be completed. There we go. And if I go back to our tests here, we can see that some of them have failed. So let's rerun the failed jobs, rerun. Now, in this case, we actually do, or we should actually find a task in ClearML that has all our code changes, and it should work just nicely. Right, we're back. This actually worked totally fine this time. So it actually only took 25 or 35 seconds, depending on which of the tasks you run. But task stats to comment was successful. So this means that if we now go to the pull request, we see our little checkbox here that all the checks worked out perfectly fine. And if I go in here, you can see that the actual performance metric of series 1 is right there. So that's really, really cool. We just changed it and there's already an example there. Right. So that was actually the first one, task stats to comment, which is really handy. You can just slap it on any task and you'll always get the output there. If you add a new commit to your PR, you'll just get a new comment from these checks just to be sure that it's always up to date. Right, so let's get to the second part. We now have, oh, these are all the jobs. So we had our task stats to comment. What else might you want to do with GitHub CI/CD, right? Another thing you might want to do is compare models. Basically compare the output of the model, or like the last metric that we just pulled, from the current task, which is the task connected to the PR that we want to open, or that we've just opened, and compare its performance to the performance of the best model before it, right? So we can always know that it's either equal or better performance than last commit. So if we go to compare models here, and we have our environments again, so this is all the same thing. We run again on Ubuntu 20.04, we check out the code, we set up Python, we install all our packages, and then we run compare-models.py. Compare-models.py is very, very similar. It is very simple. So here we say we print running on commit hash, which we get from the environment that we just gave to GitHub. And then we run compare and tag task, right? So what we want to do is basically compare, and then if it's better, tag it as such, right? So if I do now current task is get ClearML task from current commit, which is basically the same thing that we used before in the last check. Basically, it goes to ClearML to check if there's already a task that has been run with this exact same code as in the PR. So we get the task from there, which is the current task, and then we want to get the best task as well. So in this case, it's very simple to get it. So you just run get task, give the project name to the project that we want to run in right now, give the task name, which will be the same probably as the one that we're running now, but also with the tags best performance. And then if I go into our ClearML overview here, what you'll get is the best performance here, because our checks already run. So you saw the 3 checks right before we opened the PR. So basically, the dummy task here was found to be the best performance, and it has been tagged. But that means that every single time I open a PR or I update a PR, it will search ClearML and get this dummy task. It will get this one, and then we say, if we find a best task, if not, we'll just add best performance anyway, because you're the first task in the list. You'll always be getting best performance. But if you're not, then we'll get the best latest metric. For example, get reported scalars, get performance metrics, get series 1, and get Y. So the Y value there. So this could basically be the best or the highest MAP from a task, or like the highest F1 score from a task, or some such. Then you have the best metric. We do the same thing for the current task as well. And then it's fairly easy. We just say, hey, if the current metric is larger or equal than the best metric, then this means we're better or equal, we're good to go. Current task, add tags, best performance. If not, this means the current metric is worse, and the PR you're trying to merge actually has worse performance than what was there before. we at least want to say that, but you could also easily say, I want to raise a value error, for example, that says must be better. And then the pipeline will fail, which can allow you to block the PR until it actually is equal or better. Right, so now it's time for the third check and the last one as well. This is a little more complicated, so that's why I kept it for last, but it's a really cool one as well. Specifically, we're going to be using the remote execution capabilities of ClearML next to the CI/CD. So we'll basically test if whatever you want to add to the main branch, so whatever is in your PR, we want to check if that code is even remotely runnable using a ClearML agent. Because most of the time, what you want to be doing is you want to be running stuff locally and testing locally and iterating very, very fast. And then whenever your code is good to go, you want to check if that actually runs on a remote machine, because that's where you want to end up doing the real heavy lifting, the real training. So the only thing we want to check is there anything missing from the requirements? If there's anything other that might break, if it's going to run on the remote machine. The cool thing about that is that you know for sure that every commit on the main branch is also runnable on a remote machine, just to be sure. So how can we do that? We can add again our environment variables so that our runner has access to ClearML. We run it on Ubuntu 20.04. We check out, this time we check out specifically to the branch, because sometimes the agent might have issues with that. So we want to make sure that we are actually in the head SHA. And then we set up our Python environment again, we pip install ClearML, and we also add some ripgrep function that we'll just use in just a second. Now, the first thing we want to do in this whole pipeline is we want to start the task remotely. We want to make sure that it doesn't fail, and then we actually want to pull every so often to capture if it starts its iterations. If only one iteration is already reported, it means that the loop, the main training loop, will probably work just fine and we can quit it there. So that's exactly what we're going to do. First step, launching the task. So we want to start the task here. We'll give it an ID so that we can actually use the output of that process. And then there is this small tool that not a lot of people know about, but it's actually ClearML task as a command line utility. And the cool thing about that is ClearML task allows you to basically run any kind of GitHub repository remotely from the get-go. So you don't have to add anything to the code to begin with, right? So in this case, this is perfect because we just checked out our code, and the only thing we want to do is throw that to a remote machine and make sure that it works. So what we're going to do, let me just copy paste this for a second so that I can show you. I'll open my command line here. So what I'll do is I'll put it into a queue that is non-existent so that it will fail, but that will see the output just to be sure. And then I'll make sure that the branch is gone here because it's an interpolated value that we don't have in this case. So if I run this in my GitHub Actions example repository here, what it will do is it will launch the task on a remote machine using ClearML agent. So it will set up the requirements, it will set up everything, and it says new task created with this ID, right? Of course, we can't actually queue it because the queue is non-existent, but what we want to do here is we use this command to actually launch the ClearML task, and then we use ripgrep to basically get this task ID out of the console output. We'll store that into a value GitHub output that we can access here. So we'll give this task ID that we just started on the remote machine to this Python file, which we'll check out right now. So it's again very simple. So we check the task status of the first argument, which again will be the task ID. We'll check the task status. We'll get the task itself, which is the task object from ClearML. We'll start the timer, and then we'll say if we have a task at all, right? If it might have broken somewhere. So always check. If the task exists, we check for a timeout, right? For a while. So what we want to do is a while loop where you say, okay, whenever the time that I've been checking has not been longer than a certain timeout, I want to be polling the task and making sure that it's still running, right? So I get the task status, which hopefully should be either queued, pending, in progress, or whatever. Hopefully not failed, of course, but that can always happen. So we get the task status, we print some stuff, and then if the task status is queued, which means that there are tasks in the queue before it, and it can't actually be run yet because all the agents are currently working, we actually just want to reset the timer. So we reset the start time to be time.time, which basically will not allow this timeout to be triggered. This is kind of nice because we don't want the timeout to be triggered because it's waiting in the queue, like there's nothing happening to it. So we only want the timeout to be started whenever it's actually being executed by a ClearML agent. So we've resetted the timer. At some point, the task status will change from queued to anything else. If this task status is failed or stopped, it means we did have an error, which is not ideal, which is exactly what we want to catch in this case. So we'll raise a value error with saying task did not return correctly, check the logs in the web UI. You'll see probably in ClearML that the task will actually have failed, and then you can check and debug there. Also, raising a value error will actually fail the pipeline as well, which is exactly what we want. We don't want this PR to go through if the pipeline fails because of a task that can't be run remotely. This is exactly what we want to catch. But if the task status is in progress, we go into a next loop in which we say, okay, if the task get last iteration is larger than 0, basically if we get only one iteration, it means that the whole setup process was successful, the model is training, and we're good to go. So in that case, we just clean up, we've just checked everything is good, so we set the task as mark stopped, we set the task as set archived, and we return true, which basically says, get the task out of the way, it shouldn't be in the project anymore, we just checked, everything works, get it out of my sight. Right? So that was the last of the 3 checks that I wanted to cover today. I hope you found this interesting. If we go back to our PR here, it's really nice to see all of these checks coming back green. It's very easy to just use the ClearML API and even ClearML Task, for example, to launch stuff remotely. It's not that far of a fetch either to just think, why not use ClearML agent as, for example, a test bed for GPU tests, right? So you could very easily add things to the queue for the agent to work on and then just pull its performance in this way, or like pull its status in this very way. So you could actually run tests that are supposed to be run on GPU machines this way because GitHub doesn't automatically, or doesn't out of the box allow you to run on GPU workers. So it's just one of the very many ways that you can use ClearML to do these kind of things. And I hope you learned something valuable today. All of the code that you saw in this example will be available from a link in the description. And if you need any help, follow us on Slack or join our Slack channel. We're always there, always happy to help. And yeah, thank you for watching.